Okay, so Galileo made a splash with his announcement in the Starry Messenger in 1610 about the sunspots, the mountains on the moon, and the moons of Jupiter. And he became a continental superstar overnight, not only with the professors and the church people, but with the average, closer down, to the average Joe, the average people in the street. Knew who Galileo was because he wrote it in Italian, and you can buy it, you could come across it, and you could read it yourself. So, sort of more of a democratic, more democratic in the sense of spreading knowledge. But this didn't really make any real difference, really, in the end, in the battle between the geocentric model and the heliocentric model. Okay, which is the question we're dealing with this week. Which one's right? The heliocentric or the geocentric? But there was one observation he made a year or two later in the years following that really absolutely demolished the geocentric model and really got the philosophers shorts in a wad. Okay, and that was the observation of the phases of Venus. So what I've got here are two drawings of the Earth, the Sun, and the orbit of Venus in both models. Let's look at the geocentric one first and see what it looks like. So Earth is in the middle. The Sun, of course, is going to be going around it. And Venus is going to be orbiting around on her epicycle, right? Now, this is all moving, right? The epicycle is moving in the deferent, the Sun is moving too, but all we're interested in both these drawings is the motion of Venus alone and the orientation of Venus relative to the Earth and the Sun. So we're not going to worry about the motions of the Earth or the Sun in either one of these drawings. Okay? It's the orbit of Venus that's important. And here's the deal. The two models, the two theories made different predictions for what the phases are that we would see with Venus. Venus, in both models, goes through phases, kind of like the moon does. But the order of the phases and the possible phases are different in the two models. And so the question is, which set of phases do we see? This set or this set? Let's look at the phases here and see what we can expect if the geocentric model is true, and then how that's different from the heliocentric model. And in both cases, I've put Venus in her orbit 6 points around her orbit. Okay? And so let's look at what the phases are. So I'm going to step down here. 1, 2, 3, 4, 5, 6. And I'm going to draw what Venus should look like. Okay? So in this case, at 1, Venus is full. Venus is opposite the... Venus is new. Venus... I was getting ahead of myself. Phase 1 here, we're looking at the dark side of Venus, so Venus is going to be new in this case and be all dark. By the time we get to 2, Venus is going to be a crescent. It looks like a waxing crescent. Kind of like that. At 3, Venus is going to be about half full on the right. But then when Venus gets to 4, it's going to go dark again. And then over here, it's going to be half on the left-hand side, and then at 6, it's going to be a crescent on the left-hand side like that. Okay, now there's more details to these phases, but at these locations, these are the phases predicted by the geocentric model. I'm going to make this nice and bright here with a new pen. Okay, so there's a certain set of phases, 1 to 6, that you can expect to get if the geocentric model is right. This is supposed to be completely new again. That is completely, by new I mean dark. In here, So those are the phases we expect from a geocentric model. Galileo knew it. Other astronomers knew it. All over Europe, they all knew it. Heck, even the Chinese probably knew it. But this is what you get, and the people at in the church at the time knew that this is what you should get. The heliocentric model, if Copernicus is right, we should see something different. If Copernicus is right, then at 1 we should have a full Venus. At 2 we should have a Venus which is mostly full, a gibbous Venus. At 3 we should have a Venus that is bright on the right. At 4 we should have a new Venus. At 5 we should be half full on the left, kind of a third quarter Venus. And at 6 we should have, again, a gibbous Venus, like that. You can see that these predictions of the two theories are different. But nobody could see if which one was actually true, because our eyes wouldn't do it. You can go out at night and stare at Venus all you want to through its whole orbit, and you're never going to see a phase with your unaided eye. But if you get your hands on a telescope, like Mr. Galileo did, then you can watch Venus and you can see the phases. Copernicus, 70 years earlier, said, "I wish we could see the phases of Venus, because then we would know which one of these is right and which one is wrong." Well, Galileo did the work. He had the technology. He showed up and did the work and showed that this is what you got, not this. So Galileo showed that the geocentric model was no good. With this critical observation. Okay, so you would think, naively, that proves the heliocentric system, right? Right? If we got two choices, simple logic, and Galileo disproved this one, which he did with this observation, then we can say confidently that this one is right. Well, that would be right if there wasn't actually a third model that I'm not mentioning out of the interest of time. There was another model that made the same predictions of as the heliocentric model for the phases of Venus. Okay. It was a third model that was actually very well appreciated at the time of Galileo, called the this is my not a good marker, called the Taconic Model. Okay. And this model was actually in the play. Now, Galileo never made mention of the Taconic model at all in any of his work. He acted as if there were only two models possible. And because he disproved one, the other one had to be the answer. But that's untrue. At the time, the Taconic model was actually the one favored by most astronomers. And in this model, you have the Earth staying still. Okay. Mars and Venus go around the Earth. The Sun goes around the Earth. Okay. Actually, let me back this up. I'm sorry. I'm going to draw this correctly. This is not in your textbook. So in the Taconic model, sorry to say this, you have the Earth. I'll get this right. Please forgive me as I just made a little typo, that's all. In the Taconic model, what you have is the Earth in the middle. the sun goes around the earth, and all of the other planets go around the sun, except for the moon. Okay? So forth and so on. So in the Taconic model, the earth is still stationary. Sun goes around the earth. Mercury, Venus, Mars, Jupiter, Saturn all go around the sun. This is a third model, okay? And so the question now is not geocentric versus heliocentric, it is heliocentric versus Taconic, but Galileo never addressed the most popular model of the universe in his time. He acted as if it was A or B, couldn't be A, therefore had to be B. He forgot about C. Actually, he didn't forget about it, he just avoided it because it wasn't convenient. But anyway, don't get me started. That's the deal. That's the phases of Venus, and that was the really the observation that made the most scientific, had the most scientific power. Okay, and he did in fact discredit the geocentric model, but not the Taconic, because the phases of the Taconic of Venus and the phases of Venus in the heliocentric are the same. So he did not distinguish between these two. Okay. That's Mr. Galileo. He did a lot more too. He was quite the guy. But that's it for this video, I think. Yes, it is.